So, what's the best way for network engineers, architects, and administrators to access the devices they manage? Apart from the initial setup and network outages, the console port is rarely used. This means that the rest of the configuration is done remotely. So what about protocols such as Telnet and HTTP? Well, like we talked about in the Cisco Core Security Concepts course, without the appropriate encryption, anyone who is able to capture the traffic with a program such as Wireshark would be able to see the data in plain text. Furthermore, if they captured at the correct time, they would even be able to see the password used to log into the device. So while Telnet and HTTP do provide remote access to the device, they are not secure. For example, here is a packet capture that I took of a Telnet session to a switch. I am establishing a Telnet session from 10.10.10.1, which is the client, to 10.10.10.2, which in this case is a server. And I have filtered this PCAP just to show the relevant packets. So one way to find the password is to look at the data section of the Telnet packet by packet. This first packet here is from the server to the client asking for the password. And then each subsequent packet from the client back to the server is when the client was entering the password. So here's a G, and then an L, and then an O, and then so on. An even easier way would be to leverage Wireshark and right-click on the TCP packet and click on Follow, and then TCP stream. And there's the password, global123 with a capital G, right in plain sight. The same thing goes with HTTP. Here is an HTTP packet, again from the client of 10.10.10.1 to the server of 10.10.10.2. And then if we expand the HTTP section, and here if we expand the authorization section as well, we have the username and password right here in plain sight. And while right now I'm just focusing on the passwords being captured, just remember that every subsequent packet will be in plain text. So not only is the password being compromised, any data, including sensitive information, such as social security numbers, credit card numbers, or proprietary information, can easily be captured and then stitched together to get the full information. This is why encryption is so important, both for data at rest, but also for data in transit. Even if an attacker was able to capture the packets, they would not be able to see anything inside of the HTTPS payload or SSH payload. Let's take a look at the packet capture of SSH traffic. And this time, if we go through the packets between the client and the server, all we can see is the SSH headers. Everything else is encrypted. The same goes for HTTPS. This was taken between my computer and Pluralsight. Again, just like you saw with SSH, all of the data payload between my machine and Pluralsight is encrypted. So even if someone captured this traffic, they wouldn't be able to see any of the data. While we wouldn't want anyone on our network just sniffing around so they can see the source and destination information, encrypting the payload is just one more example of our defense in-depth posture. And these PCAP files are available in the exercise files for this course.